We all know mechanical ventilators are these incredible, life-saving machines, right? But what if? What if the very energy they use to help someone breathe could also be causing some hidden harm? Well, this is a huge dilemma in intensive care, and today we're going to explore how a surprisingly simple equation might just be the solution.
And that, right there, is the big question we're tackling today. It sounds like a total paradox, doesn't it? But really, understanding this is the key to improving safety for millions of patients around the world. So let's dive in. How does this actually happen?
So, this hidden danger, it's not some new discovery. Actually, it has a name, and it's been a real thorn in the side for ICU doctors for decades. It's called ventilator-induced lung injury, or VLI for short. And think about what that means. The very physical force of the air being pushed into these super delicate lung tissues can actually cause damage, inflammation, even more injury. The very act of life support carries its own risk. Okay, so here's the thing. We can't just stop using ventilators, obviously. The real key, the solution, is to get way smarter about how we use them. And it all boils down to energy, the sheer physical force being delivered to the lungs. If we can measure that energy, we can start to manage the risk. And that leads us straight to the heart of the problem, actually measuring that power. Because while it sounds simple in theory, trying to quantify it at a patient's bedside has been, well, incredibly difficult in practice. This energy has a technical name, mechanical power. It's basically a single number that wraps up everything important: pressure, air volume, how fast the patient is breathing, the whole shebang. It can predict the risk of VILI. So, if you can measure it, you can manage it. But, and there's always a but, right? Yeah, there is a catch. And the researchers behind the study put it perfectly. They said, the pitfall of mechanical power is its mathematical complexity. Basically, the math is a total nightmare for doctors who need answers fast. And this slide just lays it all out so clearly. On one side, you've got the gold standard. Yeah, it's super accurate, but the math is so complicated it's basically useless in a busy ICU. And on the other side, that's what doctors actually need. Something simple, something they can figure out in seconds, right there at the bedside. So this is where things get really exciting. This is the breakthrough. The researchers basically asked, what if we could create a shortcut, a simple, universal formula that gives us the same answer without all the crazy math? And you know what? They did it. They came up with this beautifully simple formula they call the equation. And honestly, this little equation is the hero of our story today. Just how simple are we talking? I mean, look at this. It's almost ridiculously easy. All a doctor or a nurse has to do is look at the ventilator screen for two numbers that are already there. The mean airway pressure, that's the M, and the minute ventilation, that's the N. Then you just multiply them. That's it. It's literally simple multiplication. And the benefits here are just massive. I mean, the simplicity, obvious, but it's also universal. It works on different types of ventilators. This is what finally makes it possible to track this stuff in real time for pretty much any patient. Okay, but wait. An idea this simple, this elegant. It almost sounds too good to be true, right? You have to prove it works. So how could they be sure this quick little calculation was actually reliable? Well, they put it to the test. A really, really rigorous test. They didn't mess around. They used a high-tech lung simulator and just threw everything at it. We're talking 4,000 different scenarios. That's a massive range of different patient conditions and ventilator settings. And the results? Honestly, they were stunning. They compared their simple formula against that complex gold standard method, and they found a correlation, an R-squared value of 0.931. Now, in statistics, a perfect one-to-one match is 1.0. So 0.931, that is incredibly close. So let's break that down. What does that number actually mean? It means their simple multiplication was a near-perfect stand-in for this super complex calculation. It matched the results with over 93% accuracy across all those 4,000 scenarios. That's just wow. And they didn't even stop there. They created these simple little formulas that let a clinician take their number and convert it into a super precise prediction of the real mechanical power. You just plug it into the right formula for the mode you're using, and boom, you've got an incredibly accurate result. You know, this is so much more than just some interesting research paper. This is a potential game changer for how patients are cared for right there at the bedside. So, what does this all mean for patient safety? Well, for the first time ever, doctors and nurses can easily keep an eye on this major risk factor for lung injury. They can see the numbers in real time. If the power starts to creep up, they can make adjustments right away, maybe even stopping damage before it starts. This could lead to so much safer ventilation and better outcomes for everyone.
When you strip it all away, what this research does is give clinicians a simple yet incredibly powerful tool. It's a tool to help them protect the people who are at their most vulnerable.
And it really leaves you with this incredible thought, doesn't it? After all these years of complex research, could something as basic as simple multiplication really be the key to making mechanical ventilation safer and protecting millions of lungs all over the world?